For Chapter 9, we're given some formulas to work with for surface area and volume, and they're listed in this order. The first in each column is a prism. The second one is a cylinder. Third is a pyramid. Fourth is a cone, and the last one is a sphere. So we have those to use as we go through and solve. So the first one we have is a right prism, and whenever I have a prism, I like to focus on the base. So in this one, the base is 10 by 3. So the area of that base is 30. And the perimeter of it is 10 plus 3 plus 10 plus 3, it's 26. So now when I go to find the surface area, it's perimeter times height plus 2 times the base area. Perimeter is 26. Height is 4 of the whole thing, plus 2 times 30, which is our base area. So I have 26 times 4, which is 104, plus 60, I get 164 inches squared. For volume, our formula is base area times height. Well, we already have the base area is 30, the height is 4, so it's 120 inches cubed for the volume. And number 12, the height is 12 and the diameter is 10. If the diameter is 10, I'm going to put the radius as 5 because that is half of it. My formula says 2 pi RH plus 2 pi R squared. So I'm going to do 2 pi, radius of 5 times 12 plus 2 pi times 5 squared. 5 times 12 is 60, times 2 is 120. 5 squared is 25, times 2 is 50. So our answer is 170 pi, that is feet squared, and it said leave in terms of pi, so we'll leave it as that. The volume formula is pi r squared times height. Our radius is 5, height is 12. So I get pi times 25 times 12, which turns out to be 300 pi, and that's going to be feet cubed. Number 13, we have a square with a base of 8 by 8. We have a height of 10. We got to find surface area. So to find surface area, we're going to need slant height. So I'm going to take a slice out and make our right triangle, which is going to help us find slant height. I'm not going to use 8 for the side down here. I'm going to make it a 4 because it's half of it. So it's L squared equals 10 squared plus 4 squared. We get 100 plus 16, or 116. So my slant height is the square root of 116. I'm just going to leave it at that for now. I'm also going to kind of draw my base here, which is an 8 by 8. So my base area is 64, 8 times 8. And the perimeter is going to be 32 because it's 4 sides of 8. And I get 32. So my formula for surface area, I got 1/2 perimeter times slant height plus base area. So let's go 1/2, perimeter is 32, slant height is square root of 116, plus the base area of 64. I get half of 32 is 16, so put that there. Now that wants to the nearest tenth, so we're going to go through and we're going to round, so I'm going to do 16 times the square root of 116, gives me about 172.3. I'm going to add 64 to that, and I get about 236.3, and that is meters squared. For volume, it's a little nicer. Our volume is 1/3 base area times height. Our base area was 64. Our height was the original height that we got over here at the 10. Got to remember, surface area wants slant height because it wants it on the surface. Volume wants the inside because it's the amount of space inside. So we'll put 10 there. So that's going to be 640 divided by 3, and that comes out to be about 213.3 meters cubed. For number 14, we have a height of 12, diameter of 10. So that means our radius is 5. we need to find the volume. So our volume formula for a cone is 1/3 pi r squared times height. So that's 1/3 pi times 5 squared times 12. I'm going to take 1/3 of 12, so it's really just going to be 25 times 4, and I get 100 pi feet cubed. In here on B, it's saying what is the mathematical relationship between the volume of the cone and the volume of the cylinder. If I look at what I had before, I had 300 pi, and then now I just found 100 pi. They had the same base, they had the same height, but it turned out this one was 3 times bigger. And we can see that because this one has a 1/3 pi r squared times height, where this one is just pi r squared times height. So the relationship is the volume of a cylinder is 3 times greater than the volume of a cone. And that'll always work, and it goes back to the formulas that we have. Last, we had the volume of a sphere, or the surface area and volume of a sphere. Diameter is 18, so we're just going to say the radius is 9. Our surface area formula is 4 pi r squared. So I get 4 pi times 9 squared, which is 4 times 81 pi. 81 times 4 is 324 pi inches squared. Volume is 4/3 pi r cubed. So we'll do 4/3 pi times 9 cubed. 9 cubed is 729. And what I'm going to do here is I'm going to divide by 3, multiply by 4. So if I divide that by 3, I get 4 times 243 pi. And then I get 972 pi inches cubed. Now for 16, we're looking at a 3-dimensional figure. We need to choose the shapes that can be created by the cross-section horizontally, vertically, and at any angle. So let's start with the sphere. No matter how I cut a sphere, I'm going to get a circle. I'm not going to get any squares, rectangles, or triangles because I don't really have any edges. Now for a cone, if I cut straight across, slice through, I'm going to get a circle. If I cut down from the top, from the very top, the very tip at the vertex, I could get a triangle. And there's other shapes, but not really going to get any others. A cylinder, if I cut horizontally through to the base, I get a circle. If I cut straight down from the top, it could be a rectangle. It could technically also be a square if the diameter and the height were the same. So it's possible, but really we want to think rectangle. A right rectangular prism. Well, that I'm not getting a circle. That's for sure. Square depends on the dimensions. Rectangle, that's possible as well. And I could even get a triangle if I cut through like a corner, a slice, cut a slice off. If you're not sure, if you went and got a right rectangular prism and you think of like a piece of cake, and you went in and just kind of cut this corner off, it would cut through as a triangle. 16E, a pyramid with a square base. Well, if I cut even to the square, I could get a square there. A rectangle, depending how we turn it, it's not really going to work because once it starts shrinking in, it's not going to help us there. But you could get a triangle if you cut down from the top. A pyramid with an equilateral triangle as a base. So that one we can definitely get a triangle. From the base, if we cut down from the top, it'll be a triangle. A rectangle, a square are probably not happening. Now onto our last one here. Maureen is opening an ice hotel. The structure and the furniture are made out of ice. Sounds cold. She must determine the weight of some icy furniture to decide the size of the crane needed to lift each piece into place. Maureen knows that the ice weighs approximately 62.4 pounds per cubic foot. So we need to find the volume and then figure out the weight. So the stage is a prism that's 22 by 15 by 4. So its volume is I just multiply 22 times 15 times 4, and I get 1,320 feet cubed. Now I know it's 62.4 pounds per cubic foot, so I'm going to multiply those two together, because for every cubic foot it's 62 pounds. So if I have 1320 times 62.4, I get that it is 82,368 pounds. A cylindrical pillar that has a diameter of 1 and a height of 9. So if the diameter is 1, the radius is 0.5 or 1/2. So our volume is pi r squared times 9. Now I'm just going to get the decimal here, plug this in the calculator. So I'll do 1/2 squared, which is 1/4, times 9, and then times pi. And I get the volume is about 7. We'll just say 07 and round there. Well, I'm just going to make that feet cubed and then multiply it by 62.4 pounds per cubic foot. I'm going to leave that just in the calculator and just go now times 62.4. So I don't have to worry about the rounding being cut off. And I get it's about 441.1 pounds. If it asks for the whole number, you could have said 441, nearest tenth, 441.1, and just pay attention to the rounding. A sphere with diameter of 2 has a radius of 1, so its volume is going to be 4/3 pi times 1 cubed. So we're really just going to go 4 divided by 3, which is 4/3, times pi, which is about 4.1, we'll just say 89, but I'm really going to leave it in the calculator. So I now multiply it by 62.4, and we get it's about 261.4 pounds. That's a lot of heavy ice.